Hello everyone, it's November the 14th. Alright, let's get right into it. Iterator for combination. Iterator for combination. Do we have to return an iterator for creating combinations? How do we create combinations? I vaguely remember. Oh, look at that. We have to design a class. Next has next. Okay. We give a string character, combination length. Initializes the object of a string characters of sorted, distinct, lowercase English letters, and a number combination length. Next, return the next combination of length in lexicographical order. As next return true. Oh, okay. So we go A, B, C. So I have to A, B, A, C, and B, C, and false. Okay. 10 to the 4th times call. Current length 15. I mean, character length is 15, so it is possible to obtain, or is it possible? Well, combination will be 15 factorial. No, it's not possible. 15 factorial is humongous. So no, we cannot save everything in memory. That's why it has to be a combination. All right, so we just need to do what iterator does, which is pause, right? That's what we need. So we need to remember the state that we are right now and then produce the next combination. No, next combination. Next combination. Wait, that's actually, it's not really combination, it's permutation. Is it combination or permutation? No, it's combination. My bad. It is combination, but combination with what? With order. So that's not 15 factorial. What I was thinking. So it's going to be 15 choose whatever value. All right. 15 choose, well, the highest will be in the middle. So 15 choose like 7 or 8. 6,000. Well, in total is 2 to the 15th, right? 2 to the, wait, is it 2 to the, I forgot, 2 to the 14th, right? I mean, like, if there's 3, choose 2 is 3, choose 1 is 3. That's 6. So it's 1, 3, 3, 1, right? It's 1, 3, 3, 1. You choose 1. Choose 1, choose 2, choose 3. Actually, choose 0. We'll start from choose 0. Choose 0 is 1. So 1, 3, 3, 1 is 8. So 2 to the 3rd, right? So the total number of combinations from choose 0 to choose 3 is 2 to the 3rd, that's 8. So for 2, can be 1, 2, 3, 4. 1, 2, 1, right? So it's be 2 to the 15th. 2 to the 15th is not that big. Like we can technically create the entire list of combinations sorted in lexicographical order. And then we just return that. Remember the current position, just return that. Yeah. There's actually no, because it says combination length. It already gives you the length. So all we need to do is just create the entire thing. I mean, apparently that is not what the question intends, right? You're not supposed to do it, but because the length is 15, so it's possible. It's possible just to create the entire list of combinations, sort them in order, and then we do the iterative thing like that. I mean, in Python has iterator. We can even use, like, I mean, the easiest one would just be, say, self.com equals let's do from itertools import combination. Well, I actually don't know. Is it combination or combinations? And a combination is itself a combinations. All right, combinations, iterable, and choose R. But does this give us? Well, we can sort it. So combinations. So we can just say combinations characters and combination length. Right. Once we do that, then we sort it. Right. We sort this. So once we sort this, this is going to be an iterator itself. So the next, we simply call, let's say return next self.com. Actually, wouldn't that be easier? I don't know. Next call this. What if I run out? Guarantee that are valid. So how do we check? I don't know. Python iterator check has next. How do we check? Maybe there's no such check. Next default value. Sentinel. All right, so how do we do has next? Oh, then we just change it because I said it's not that big, so we can just list it. All right, so I can just turn this into a list. Oh man, looks ugly. All right, so we turn this into a list. And then, wait, sorted, that return a list? I forgot. Sorted return a list or 312, okay? So called sorted return. Yeah, it returns a list, doesn't return iterator. So I can just sort it. I'll call this a list, and yeah, and then self.index start with 0, right? And then next, just return self dot, no, actually, val equals self. Actually, we can just increment it first, self.index increment, and then we're going to return self.combination, self.index -1, and it has to be just return self.index is smaller than len self.com, right? If it's smaller, yeah, that would be cheating, right? Wait a second. Wait a second, I need to return this. Oh my god. Alright, so woo-wee. This one turns the original into a list of strings. A list of strings. That is not what I had expected. Well, we can make amends. So we're gonna do a list comprehension here. We just say for C in combinations. So we're gonna do this dot join C. Okay, try again. Yeah, so this one will pass, but I'm pretty sure that's not what's intended. Ah, okay, done this before, a long time ago. 499 days. But this is what I did initially, but we need to find a real solution, right? We need to find a real solution. Okay, a real solution, which means we will do the combination ourselves instead of relying on this. Well, the hint is when we're given the characters, they are already sorted, right? So we already have, say, ABC coming in, and let's say we want a combination length of 2, right? A length of 2. So usually when we do combination, I'll use recursion, right? I say I take A out. Now among B, C, I need to choose 1, right? And then I'm gonna choose 1, and basically just B, C, choose 1, which will be also lexicographically sound. And then once when done with all A's, then we move on to B. And now when we start with B, we can just go the remaining. We don't have to involve A again. Okay, so the question now is, can we do this? I mean, I can write like this, right? Let me just do another one. So again, since the question itself has limited size, if we want to avoid, say, like this is like blatantly cheating, right? It's very, very blatant, abrasive cheating. Another way to do cheating is don't use combination, right? We can produce our own combination. We don't have to rely on the built-in library. And for that, we can simply create a function, right? I'm going to say def comb, right? Def comb, and we will have characters, right? And combination length. That's what we need. And we're going to return a list of strs, which are the same as this thing. So basically, we're going to call this self.com characters and combination length. Now, actually no. This one will create a combination because the characters. Let me think about this. Oh, it should be fine. So what do we do? Well, we also need an index. So I do need index here. So we need an index here. And this index will be passed here. So we start from 0. That's the first one. Start from 0. So what do? We say, and this one, which is the quote, that's character. This one cannot change. This one will change. This one we just say com length, right? Let's put com length. This one will change. So we have first company, we have the index, and we'll say when com length equals to 0, right? When com length equals to 0, I shall return an empty. So I say if not, right? If not combination length, that means we have end, then we just return an empty array, right? Otherwise, I look at my current index, right? So I'll say I'll start from current index, and the remaining will give me com length minus 1, and I'll go to the next one, right? So we just say for I in range from my current index, right, all the way to len characters. I'm going to say the remaining, right? The remaining will be, actually I need a result, right? The result, and the remaining will be self.com index plus 1, right? Index plus 1, and characters is not changing, which in this case I feel like I can simply just do self.cat chars equals characters. Therefore, we don't have to pass in this. Right? There's no need to pass, and this will just be len self.chars, and then this will be combination length minus 1. Right? So this one will give us all the combinations right down there, and I am pretty sure this one can be cached. Yeah, I feel like this can be cached, so I'm gonna cache it. So let me say from functools import aru cache. So I'm gonna cache this function. Aru cache size max size equals none. So I'm gonna cache this right function, and I'll do this. This is gonna return me a list of strings. Now what do? We're gonna say res gonna be plus equal to, which also res.extend. I think I use extend, right? And then it's gonna be a new list. And for this new list, we're gonna say for C in this, and we simply add self.chars I, right, plus C. And res gonna extend this. And I will go every single one. Once we're done, we're gonna return res. So that's that. Let's see if this one works. Okay, I run code. List out of range. That is interesting. Self.combination. Index out of range. Combination length, right? So I do length minus 1, and then index plus 1. And now I pick that, will be index with 0. So basically, it's just going to be by itself. Let me print it out. Self.comp. I think I spelled it wrong. I spelled it chem. Oh, that is interesting. It didn't return anything. Wait, does it extend? All right, let's not do extend then. Let's just say plus equal to plus equal to this. I feel maybe extend needs to be res equals extend. Nope. Nope. That is weird. Now I don't know what happened. We start with index 0, right? And still, output is just nothing. Start with I is 0, right? And the test case is ABC. So start with 0, so A. This one shall be A plus whatever for C in self.com. So that should be 1. Index plus 1. Maybe it's not index plus 1. Shouldn't this be I plus 1? Yeah? I think it should be I plus 1. So I'm looking at my current index, right? And then I go my I plus 1, so the remaining can only produce whatever I have. Once I'm done, I'm going to move my I to the next position, right? So next position, and then I'll have a new remaining. Yeah, it is I plus 1. Is that? I don't feel like that's the cause of the issue, though. Nope. Hold on, let me think. What happened? For I in range, I mean, for one thing, we're not gonna go all the way to this because I have a length, right? I have a length. Index plus 1 and a combination length minus 1. So eventually we'll hit a value which just becomes 0. And then we'll keep going on. So, okay. So for I in range, index 2, length minus combination length. So for here, we have ABC, combination length is 2. So 3 minus 2 is 1. So 0, 1. The maximum I can go is 1. So actually it has to be plus 1. Right, and this is going to be I. So for I in range 0 to the end that I can go to, I'm just going to go for plus equal. So make plus equal to self.charge I, which is the current, right? I'm going to plus C and for C in self.com, I'm plus 1, so the next one, and combination will be number 1, right? Every combination will be 1. The combination will be 1, and then this one will go to the next one, index, right? Combination 1, we do this, and then will be 0. A 0 return an empty array. Now, if that returns empty, oh, it's not empty array. I think it is this, not empty array. It's a empty string. I mean, in this case, I feel like what we can just directly do is say if combination length is equal to 1, then we simply return this, and for no, it's going to be self.chars, right? Self.chars from index all the way down, right? From index all the way down, I'm going to get length is 1. So from index all the way down, we're just going to list it, right? Just going to list it. So that is my end condition. All right. Let's give this a shot. There we go. I think this one might work. You want to try another one? Yeah, let's say B, C, D, E, F, and then we go 4, 3. That's 3. All right, let's try this. Yeah, I think this one shall be right. Yep, it is right. So this is what should I call this? LeetCode 1286, right? So LeetCode 1286. I'm pretty sure this is not what the question intended. Intended, because I did not build any. I did not build any mechanism for iterator. I simply create the entire list of combinations. I simply created that and save it in the memory, and save it in memory and produce it and iterate it through, right? And iterate it through. But this gets the job done, right? But this gets the job done. Okay, so I don't think it's necessary. What's the runtime for creating the combinations? Creating the combinations, it's O, like M choose N, M, no, I think it's N choose R, N choose R, yeah, so O N choose R, which give us 48 milliseconds, 88% ranking, but I'm pretty sure, because I'm writing this, right, I think it's possible to turn this into a yield, right? Can I like write a yield iteratively, create, and then we like do a yield with recursion. Let me think. How do we do yield with recursion? So at the last one, I said I yield, right? And then, because this is a list comprehension, and then for everyone, let's say for C in this, is going to be yield, and C, create a new one. Yeah, maybe I can just change this minimally to create a yield. How do we do so? So we do not return anything, right? This one will yield a single value. So what if not combination length? Yield this, and nothing will not return. And for I in this, then we say for C in this, all right, for C in this, then we say yield this plus C. Okay. Then what? Then how do we know if there's anything left? Again, we will not have this, and we'll have has next flag, right? So next will equal to has next. If I call has next, how do I know? Yeah, that is a question. So I call next, and I call has next is a true. Call next. Okay, I know. Yeah. So, we're gonna say self dot next is something, right? And then we're gonna call self dot next equals next self dot combination, right? Combination. Ooh. Wait. Next shall be an iterator. So self dot com equals self dot combination 0 index and this, and I just call self dot combination. This will get me the next value, and then this one will be how do I determine that it's the end? We'll call next, we'll get the next value, we'll call next, get the next value, and what if I call has next many times? You cannot just keep popping the thing out. Oh yes, I think it's possible, right? So this has next initially will just be a dummy value, right? There will always be something next. So you know what? Has next will be an empty string, right? So we call next, we say self.next equals this, right? And they say they will always have something. So we can always just do that and return. And then we just return this self.this, and we return self.next. Now once we're done has next, then we say if self.next, hold on, let me think. I grab the next thing, right? And I return it. If I call next, I grab the next thing, then I return this next thing. And then self.next shall be, which means every time I call this, self.next will go back to this, and I simply return this, right? And then to call has next, right? Say if not self.next, self.next equals next self.com, and I believe this one is where it comes in. You can call a value here, which is going to be an empty string, right? So if not next, I create the next, and I want to return the self.next is not equal to an empty string, right? If it's not equal, means we do have a next. So here, we're going to say if self.next, right? If self.next, which means there's something in there, I need to return that, and I need to turn self.next into an empty string. So I say if self.next, then temp will equal to self.next, and then self.next equals this, and we're going to return temp. Otherwise, I don't have to change. I just return the next one. So this one will be use yield. I'm not sure. Go and try it. Let's see. How does this one work? str is not callable. Where did I call it? Line 30. It didn't even say. Oh, self.next. Oh, I think I know why. Next C. Yeah, let's call it next C. The next C. So no next here. So if the next character temp equal to this, and next equal to this, blah blah blah. If not, let's C. Then C and this C. Okay. Try this. Yeah, I think I cannot use self.next. It's duplicating the name. Is not defined. Oh, of course, it's not defined. All right, again. Oh, nope. Nope. And nope. Maximum recursion hit. How is maximum recursion hit? That don't make any sense. Don't we hit here? If not combination length, then I will yield. Oh, wait. Yield is just... So after yield, it will keep going. How do I yield and return? Python, right? Yield and then return. Is that a thing? Yeah, the second one is not. The return statement also, the latter explicitly yielded a redundant. Code after the return statement. Yeah, I think I can return. It stops the generator. That's what I want, right? I want to stop the generator after, because I'm doing this inside, so I can do a return. Just make sure I'll yield it, right? And after yield, it will return. There we go. There we go. I think that's it. Let's go. Okay. Isn't that the initial test case? Oh, stop iteration. Oh, wait, hold on. If this, that's the logic. That's my logic. Okay, think again. I use this to because I need to check has next, right? So what do? We have a next, has next, next has next, next has next, right? So we call next, and that is not. I do return next, so this one will go one round. And then has next, we'll check this. If not, which is this case, self.xc equals this. And then we'll return this. If not equal, true. And come back. Next, come here. If this, yes, we have. So I will return the temp and set this to empty again. And now we call has next, so it's empty. So we'll grab it, which is good. Right, self.next, we'll grab it. And next, we're gonna call next. We'll grab it. So I'll return this. It's good. And finally, has next. I don't see why I will call this one when this. Can I print self.nextc? Actually, it'll be better. Print right here. I'm not sure if it's possible. Yeah, it's not gonna give me anything. Fool. How about that? Standard out, which doesn't give me anything. Okay. But expected is this. Get AB, I got it. AC, I got it. BC, I was not able to grab BC. I got AB, I got AC. All right. Maybe it's issue here. Okay, length is 2, right? So length is 2. We're coming in. That's 3. Minus 2. That's 1. Plus 1 is 2. So the index starts with 0, 1. Yeah, 0 and 1. Because ending is 2. So we go 0 and 1. So index is 0. And then I go plus 1. And then combination length. So I got A, B, and AC. That's fine, right? And then I will be the next one, will be 1. So I is 1. Combination is 2. So it will be 2 and a 1, right? Then go in 2 and 1. 2 and self dot length, that's 3, minus 1 plus 1 is 3. So 0, 1, 2, 2, go 2. Yeah, so it's going to be 2 and 2. So this one will produce 1 value, right? And this one will be 0. That will yield an empty. This will yield, it shall yield just C, right? This one shall yield just C. I don't know. And it didn't print anything. That's weird. Huh? Hold on, what if I do 1? 1 is fine. And 3 is fine. No, 1 is fine. And 2 is wrong. I don't get it. Oh, now we have it. empty and empty. So has next AC. So this one will return true. I'm pretty sure that's. Oh, look at this. It's false. It's supposed to be true. Yeah, so this one only produced 2 instead of produce 3 values. What the hell happened? I produced the first one, produced the second one, which both happen here, right? And then I call next. Like after yield, we should go back here, go for the new I, and call this one again. We should come in here, so yield again. Yeah, this one shall yield an empty string, and then oh no, which part did not do right? Yeah, based on this, that simply means why did the yield didn't work? Something is wrong. Something is not right. First of all, okay, this time return we have for return that we turn it off. Right? I have AB, I have AC. And then that's when index is 0, right? Index is 0. And then I go for the next one. B, combination distance is 1, right? So I'm commenting here again. Combination is 1. So index is 1. And here we'll go to 3 minus 1 plus 1, go to 3. So 1 to 3. So I can take 1 or 2, right? Yes, 1 or 2. So coming here, I plus 1 is going to be 2. So that's 2. Combination length is 1 plus minus 1 is 0. Right? Again. Ugh. I have 2 lengths, right? So when this is when I is 0, right? I was able to produce B and C, which is fine. And then coming back, so when I produce this, just I can yield B, I can yield A, B, all right? And then I'll pull again, I call next again, so this one will give me another one. I have AC, and then, so this yield is done. Yield this one is done, I'll exhaust this. So once I exhaust this, I should go back here, right? I should go back to here and then go to the next round, which this one was 1, and then we're gonna do from 2, right? Oh, 0, 1. Combination length is 2. Yes, combination length is 2. So combination is 1, so I should get a 2. That's C. Comment again, nothing. And then for C in length, oh, hold on, maybe that's K. So I'm looking at 2, and then combination length is 1. So I'll grab that value, C in the next one. So index is going to be 3. Combination length is 0. So I go in here, so I yield an empty string. So this shall be empty string. This one shall give me C, right? And then I'm coming back. I don't know. There's no BC. All right, I have to do this myself. Let me say combination iterator equals 2, right? And characters will be ABC, length is 2, and well, let's just do ci dot next print, right? Ci dot next print ci dot next. I shall be able to do how many? 3, no, 2, no, 3, A, B, A, C, and B, C, right? Ci dot next. Yeah, I can do that, but then stop iteration, so it's not enough. How? Okay, how about we're gonna let's also print ci.next, right? At each time. Oh shoot! Not next. My bad. Next C. Next character. All right. So next character is empty. That's true because I never really called it. And then empty. So it seems to me that after this yield, after I yield BC, and it stops to go back there. Okay, how about no, I don't do these calls. How about I make calls here? I just print here, see what happens here. Okay, I have I is 0 and I is 1. I probably need a combination length as well just to identify which one it is. Right, 0 is 2, and then I call this a 1 again, so 1 is 1. So 1, 1, I got B, which understandable, and then I got 2, 1, I got C, and then I'm coming back up. I have 1, 2, exactly, that's 1, 2, that should be BC. 1, 2, combination length is 2, current position is 1, and I go in here, I need to go 2, 2, 1, exactly, so I'm at position 2, I need a 1, right? Position 2, I need a 1, and I go in here, and this one will be 3, so next call, this will be 3, and this will be 0, and since it's 0, it shall yield an empty string. So this one shall yield an empty string, so C shall be empty string, and this one shall be able to yield a position 2, which is C, right? So this shall return C, but it is not. It is not. It just ended there. Maybe I think it's a syntax issue? Maybe like yield from? Is that what it is? I don't think so. How about we call these? Let's not print. Let's not print here. What is it called? We're supposed to do 3 next, right? That's what we're supposed to do. 3 next. Let me print C here, just to see what happens. I yield a B, yield a C, and this one just does not have anything. I call next self.combination. Hold on, maybe yield from? Nope, nope. But it feels, isn't it like, I feel like it's here, right? Self.com. Should not return none, not generator. I mean, it's all about yield. Yeah, not good with yield. All right, I'm gonna check. I mean, I've done this before, so let's pick. I know this one is cheating, so this one probably is my earlier method. Let's see, what's this one? Nope. No, yeah. Oh, I mean, this is the earlier method. All right. I was trying to do it myself, which is right. I mean, we did that already. We did here already. I'm gonna try. I was trying to yield method. Is this one a yield? Gotta be syntax. I haven't written yield for a long time. Nope. This is bit masking. Oh, I remember. Oh yeah, bit masking. Oh yeah, bit masking. Yes, bit mask. But still, I mean, bit mask is a good solution. I kind of remember. Combination, we can use bit mask. You know what? It's not combination, it's bit mask. We should use bit mask because bit mask preserves the order. All right, we'll take a look at bit mask later. So that's still not yield. I want a yield solution. Specifically, I want to know why the yield did not work. Why I call the next, right? And every single time the self.next is not there, so I'll have to call next this. Now when I call next this, the yield is just a stop. It just stop here, right? And then I call the next again. So this one will equal to this. This will have, all right, I know what to search. Let's try Python yield recursion. Yeah, that's the thing. I think that's what got us. Recursion using yield. Gotta be some specifics right there. Mix recursion with yield. Yield this recursion here. I want to stop after yield start. The second one is probably yield from, I guess. Yield at start and then generator and then stop. hold on, yield star for x in yield x. Yield from. What's yield from? To the new generator without actually running the function body. This is stack. I want to use yield. Yield from. Okay. Okay, I think it's here. Right? What if I say yield? I don't want to yield. Wait. I don't want to yield from. If this, for this, yield from this. This will give me a new value. But I don't want to return that new value. I want to use that new value. I want to use it. Right? So I do this, and I cannot say yield from, because yield from this would just be, and I want to yield, oh. And I just realized I don't need to return. I can just do if else. But that won't be the same. It just stop iteration. Turn self dot combination. Anything else? I don't think. Maybe the problem is here. Equals this. Yeah, if you look at this, I got in 0 and 2. I do get in here 1 1, and I do get that's the first call, right? That's the first next call. First next call, I do this, and then eventually I do yield, right? And again, I'm gonna put print here again. Just focus on the first next call, right? The first next call, I start with 0 2, and I go back in again, and then I have 1 1, and then go back in again, and then I yield, right? I yield something because I call a next, so I yield, and then I'm here because I yield, so I get this, and I continue yielding. Yeah, I think I just continue yield, and I yield this plus this, and yield this, and that's the one because I print as that's B, and I yield this. That's the one gets captured by here, right? And where do I stop? I go back up. Because when I call next, it will stop at the wait. After I call next, it will go until the yield, and it will stop right there. It will not yield until I call. I call yield, it move, and I stop there again. So initially, when this one is issued, it will execute all the way to it should be here before the yield, right? So it initially all the way right before this one, and then I call next. It will execute this, right? Execute this, and I'll print it, and I get stuck here. Hold on. What if I only have one next call? Now we can expect a little bit more. Wait. So that's one next call. We call it one time. You know what? Let's do this. So I create this, but nothing happens. Oh, okay. I create this, nothing happens. Without calling next, nothing happens. Well, actually just call next self.combination. Oh, not self.combination. ci.combination. Actually, I can print this. Yeah, so if I call next, so when I first start, nothing happens, right? We do this, nothing happens. Then we call next on this. So the code it didn't even execute this. It just stopped here. We're not executing anything. And then when I call next, it executes this line, right? And then going here, we're going here. So go to the next level, print this one. We have not hit a yield yet. I'm going here, now coming here, right? And we hit the yield because of we call it next. So we yield. And once we yield, because I call foreseeing this, that is a next call, right? So the C comes out, and once C comes out, I yield. This one's actually just yielding a B. See right here, that we're yielding a B. And coming back up, the previous level, I call it foresee, right? So this one yield B, and a foresee. So the B comes out, and then I'll yield. B comes out, and I'll yield, because for that function, that's the first yield it hits. And this yield is, this one's A, this is B. So I yield out, and I stop here, right? I stop here. Okay. Then I call it one more time. Okay, second time I call, it goes back up to this, right? And then I'm gonna yield again, yield the next one again. Okay, so I go back to the next one. So next one, I yield back in. Next one stopped at here as well. So this one will go back again, and we'll go back again to grab C, right? So C comes out, and then I yield it. AC comes out. After AC comes out, I stop here, right? And because the C comes out, so the next round coming in, so if I call next again, it will go in here. So this will be 3. So I plus will be 3, and this will be 1, right? So that comes in. Oh, hold on. Index is 3 because I do AB, AC. I'm still at A, and next round index will be 3. So when index 3 comes in, combination is still 1. So I try in here, and this one does not yield anything. And then we just end. We end like we're over. Oh, I might know what happened. So I need this one to stop, right? I need it to stop. How do I stop? Hold on. So I have A, and then we have B. So basically I is pointed at B position, and then the next one, this basically just yield an empty, right? Yield an empty. So that's how I got it. And because it's only yield once, right? Yield once. So I actually do come back, but nothing comes out. So that's how this one's ending. So I go to the next one, right? C. And then C comes out, nothing. Okay, we go back. We'll go back. So basically it's this one. I have B, I have C. So once I'm done, because this one's done, right? I have B, I have C, so this one is done. No more yield. This one's done. Right? And then next, this one exhausted. So I'll come back, which if I do, you will see we do come back, right? I am at 1, I am at 2, and then I'm at combination. Oh, hold on. It's because it's already exhausted. There we go. Oh, now I see. Now I see. I cannot cache it. Because I cache it, I need to produce C, right? But previously I produced the C already, so the cache records index as 2, combination length is 1, so this 2-1 combination return an iterator, and that iterator is already exhausted. That's why when I try to produce BC, it fails, because it simply cannot produce BC because it's already exhausted. Wait, are you saying that we cannot do cache in this case? How is this going to work if I don't cache? Well, if you don't cache, I just have to go down each path every single time. I need to go down every path in every single time because I need to yield from this again. So this might actually be slower. Wow, the yield gave me so much trouble. This might actually be slower. But this one will work. Yeah. I'd expect this to be slower. Actually not. Wait, why does yield not slower? Don't I have to go through every single one? Well, honestly, every time I call next, I get the next value. So every next call is actually 01. If you think about it, right? Every next call is 01 because I only move one step, right? Only move one step. Every single time I call next, I only move one step. And I stop there. So the next one is picking up from where the previous one is left at. And if I unwind it, then I have to go inside again. Like if I don't cache, right? If I don't cache, then I'm doing repeated work because something I have calculated before. That's interesting. I don't know honestly. I have no clue why this one. I mean, again, this is too small. Anyway, that's my yield solution. I'm not sure. I'm not 100% sure on the time complexity with yield. I feel like yield shall be slower, but it's actually not. The reason I think it's slower because I have to yield from something I've done before repeatedly, right? That's why I think it will be slower. Like if I have a cache, like in the regular programming, I have a cache, something I've done before, I don't have to go down that path again. Let's say I do starting position and ending position. Say this is a giant. This is a giant combination, right? So I've done it before. With yield, I have to go inside again. But on the other hand, right, when I call yield, each next call is only doing minimal work because I believe, well, maybe that is caching, right? You are caching the previous step. You have all the previous step cached. So when you call next, you only do the minimum, right? We only move one step forward, one step forward, one step forward. And then there's one call be unwinding. That's fine. I unwind to whatever previous position is, and I go. So every single call is short. That technically is caching. It's just different ways of caching. It's like regular DP, I say I'll cache the future, right? I have visited that future before, so now I don't visit it again. That's like a future caching. But with yield and iterator, it's like caching the past, right? So I'm at my current step. I cached all the steps that I have taken already. So when I want to produce the next combination, I don't have to go through all the steps again because I cached my past. That is a good explanation. I like it. I like it. So I had problem. I had problem with this yield method because I was using LRU cache on it. Well, this is wrong, right? This is wrong because when I cache the value of self.com, right? The iterator remains there, right? Iterator remains there such that if it has been exhausted already, a new call to self.com would not produce anything. In other words, we shall not cache, but call self.com fresh each time. However, will this increase runtime? Well, the answer is no, because using yield is akin to caching the past, whereas LRU cache, or in a DP style caching, or any memoization is caching the future, right? So that's the difference. A yield is caching the past, the steps I've done before, and memoization is caching the future, because previous one I already reached that future. So now if I want to grab that future value, I grab it immediately. I don't have to do it again. But caching is I'm at my current step, right? To get to the next one, I don't have to go through all the steps I have done already. Yeah, so that's the difference. That's the difference maker. And of course, the one thing I don't like about this is this part, but I don't see how I can avoid it. Like how can I call has next without like peaking? As this one doesn't have peak. Anyway, all right. So I think I'll end it right now, but I'll have to go through this solution again. The bit masking, which will be interesting. I feel like this is a good way of thinking about what does yield do and what does caching do. All right, that will be it for today. Tomorrow's gonna be a big day. Tomorrow's a big day. I'll see you guys tomorrow. Adios.